Out of all the stars out there in the universe, our sun is one that hosts life. Put something out in the sun and it'll grow. There are 4 billion sun-like stars in our galaxy. What are the odds of a planetary civilization like ours existing on one of these star systems?
If you look at what other stars in our galaxy has those properties, you're able to come up with this number, which the average is 36 for the number of possible planets that could host intelligent communicating civilizations.
Hey guys, what's up? Welcome back to another video.
It's about aliens.
In my video on zoo theory, I mentioned exoplanets, which are Earth-like terrestrial planets that can hypothetically harbor life. Thanks to the past decade of technological advances, astronomers have detected and confirmed over 4,000 exoplanets to date. In 2015, there were only 1,827 confirmed exoplanets. This huge upsurge in data that astronomers now have has led one team to develop a new model for determining the probable amount of alien civilizations that exist. The idea to create a model and run the numbers to make a calculation like this is nothing new, actually. It first started back in 1961. Scientists didn't have a good idea of how many stars there were. So what they were doing was they were trying to study the rate of star formation. How quickly do stars form based on physics of galaxies. That makes this new model really different from Drake's equation. In this model, the number of stars in the galaxy is fixed at 250 billion. So out of 250 billion stars, the scientists ran the numbers through their equation and found that the most probable number of active civilizations right now are 36. So how the heck did they get 36? That's pretty specific. In the formula, they multiplied the number of stars in the galaxy by the percent of stars that are considered mature, which means they are at least 5 billion years old. That's pretty old. They multiplied that by the percentage in the habitable zone of the galaxy where life is favorable. This is the idea that rocky planets that have water and warm atmospheres are able to form here because the conditions are not violent with strong radiation, basically, that comes from the galactic center. And then on the other hand, the edges of the galaxy, it's cold. So they determined the habitable zone of the Milky Way, and that makes up 19% of those 250 billion stars. So they factor that in. Then they determine the percentage of stars that have a high enough metallicity for life to form. So it turns out about 50% of the stars in the habitable zone have enough metallicity to be able to form Earth-like planets. The next variable is the average lifetime of an advanced communicable civilization. This means once a species of aliens is considered technologically advanced, according to this formula, it has 100 years until it self-annihilates. So that's lovely.
One of the big unknowns in this is how long do these intelligent communicating civilizations last? If it's very short, then you wouldn't expect to see very many. But if it's very long, say a few million years, then you would expect to find more. So by finding these, we're going to find out some idea of how long our own civilization could last.
Then came calculating the time window a given Earth-like planet has for harboring intelligent life, knowing a star system is not going to last forever. Using computer models to search for extraterrestrial life brings up some pretty interesting questions, like they had to guess how long a civilization might stick around after it becomes technologically advanced, gets some radio waves into the atmosphere, and apparently it all spirals out of control, climate change and everything, self-annihilation. It's over. 100 years.
According to this handy alien calculator.
So if we changed it to 100 years to 1,000, the equation's result would change to 355 Also, remember they use 250 billion as the number of stars in our galaxy, and there's actually a more upwards estimate of 400 billion. If we keep the average civilization's lifetime at 1,000 years, but we account for 400 billion stars in the galaxy, the number of civilizations we get with this model is 568. The other thing is the equation only factors in stars that have had 5 billion years of evolution under their belts. So the percentage of the stars in our galaxy, they're saying, that meet this criteria is only 1.5%. Then the star system gets 1 billion years. So there's these time limits that we're only basing that on our own solar system. We on Earth are 27,000 light years from the galactic center. I'm not an expert, but I would think that maybe it could affect it to where life can evolve at different speeds in different star systems. At the center of the galaxy, that's where stars go supernova, and that actually helps seed new planets. That's where the cosmic soup is stirring. I would think the probability might be different.
My personal take is that it's just very rare that these type of civilizations that could communicate, that have technology, are very rare, and that their lifetimes are not very long. Even if they're thousands of years, you still would not expect to find very many close to us. So they're just far away, and so we just haven't been able to detect them yet, and they haven't been able to detect us because we've only been emitting light, like radio waves, into the galaxy for about 100 years. And 100 light years is how far that could have traveled, but that's not very far. And so it will take thousands of years for our detections, our radio emission, to reach those other stars where possibly life exists. So it's just that they're so far away is probably the reason we haven't seen them yet, and that's what our calculations suggest.
But the fact that 36 civilizations in our galaxy is predicted, even with all those limitations, like I just literally broke down how strict those limitations are, and the fact that they come up with 36 that are not, and it's not alien life, remember, it's advanced, like technologically capable life. So I'm pretty impressed. Okay, I think that's proof of aliens' existence. Okay, aliens exist, period. It's also interesting to consider the possibility for biological life that isn't civilized. You know, basically animals that are evolving on other planets. Creatures. Ooh. There's a Netflix series that has taken what we know about temperatures and the chemistry of atmospheres and the terrain of the newly discovered exoplanets, and they have predicted what sort of creatures could hypothetically evolve and exist in these types of habitats. So are you surprised by what the math says? Do you think 36 is a lot, or do you think there's got to be way more? That's it for this one. Give the video a like if you liked it. Subscribe if you're new. I'll talk to you again soon. Take care. Bye for now.